Well, hello and welcome to this session. Here we will be covering how to work with switch statements, acceptable literal data types for switch case statements, make switch work with strings and enumerations, using switch in conjunction with if-else statements, and much more. So let's jump right in. Next, we will be exploring switch statement and how it builds on top of the else if ladder. Instead of writing lengthy else if ladders as we have seen in our previous example, we can streamline the logic using switch statements. In if-else, exactly one condition, if at all, is executed, while in a switch, if we don't use break, it will evaluate the subsequent case literal matches. Let's understand this use case using one example. So we will quickly create one class under the same package and we will call it switch demo. We'll create a main method and here let us declare one integer. We will name it switch value. Next, we will define the switch structure. How do we define the switch structure? First of all, we have to write switch keyword and then we have to write a particular literal which will be matched with the cases. So in this case, our literal is the switch value. So one thing to keep in mind is this switch literal does not accept any data type. So it has to be of type integer, short, byte, char. It can accept a string as well and an enumeration. Also, the values which is accepted by the switch keyword can be wrapper classes representing this literal, such as your integer, short, byte, character, and string is already a class, and enumeration. So we will see enumeration in much more detail in our upcoming sessions, but for now we will make do with a simple example. So now moving on, I have written the switch keyword along with the literal which is an integer. Then we will open the code block. Inside the code block, I'll write the case keyword. And then I will write the direct literal value that I want to compare switch value against. So I compare it with 4 and then I'll put a colon and then after this colon is where our code block for this particular match is starting. So I'll print out matched 4. Then I will add a break. I'll explain why this break is needed. Now once this break is done, I will move on to the next code block, which is, let's say, case 5. Again, I will print out matched 5. Then I will add one more break statement. And then I will add something called a default block. So default block basically gets executed when none of the above case matches the literal value. So this is like a catch-all block which we have seen in the if-else ladder with the final else. So when we are using the if-else ladder, there was one final else condition which got executed if none of the if conditions matched. Similarly, in this case, we use the default block. So how do this actually work? So switch value is defined as 5. So basically when we start the switch, it will come to the case and it will evaluate if the switch value is equal to 4. If the switch value is equal to 4, it will actually execute these two statements. And once this statement is executed and it encounters a break, what it will do is it will break out of this entire block. So this entire switch block execution will end and the control will jump out of this entire switch block. That is why we use a break. Break is completely optional. So if you don't give the break here, what happens is, let's say there is a match for case 4. After this output got printed, it will again match with case 5 if this break is missing. So that's why we always put a break. So when there is a match for 4, it executes the code related to 4 and then exits out of the switch block. Now, there might be some use cases such as fall-through switches and all, which we will explore in our upcoming lessons, where this scenario might be an expectation, where we have to remove the break so that it will match both condition 4 as well as a 5. So let's say I want the switch value to match both case 4 and a case 5 to print something out. So what we can do is, in that case, we can just remove these two statements and keep the block like this. So it will come to case 4. Let's say case 4 matched. Immediately it will go to case 5. And case 5 also, let's say it matches. And then it will do something. So there are use cases. For now, we will keep it simple. And we will try to run this code and see what it prints. So Shift F10 again. Here we see matched 5. So since the value that I've assigned here is a 5, it is coming here. Now let's say I want to execute the default block. How do we do that? We have to make both these conditions fail. So let me assign a 6 here. Now if I assign a 6 and then execute the code, our default block should get executed. So I need to add a message, default block message, and now again I'll execute it. So in this case, we see the default block message is being printed. One more thing to note is the default block is also completely optional. So if we remove this and let's say none of the case matched, the switch block ideally will do nothing. It will execute the matches for case 4 and case 5 and then will not execute any code blocks associated with both the cases because the literal did not match any of the value, and it will exit out of the switch block. So now if we run the code, we will see nothing is getting printed. We can actually check with string as well. So in this case, what we can do is we can try the other data types which is supported. So I'll change this into, let's say, short, and it should work. So let's say I give a value of 5 and see if this matches. I'll run it. So matched 5. So it is working with short. I will change this to byte and I'll run it again. This is matching. And I can also use a character because character internally is using an integer to represent a character or ASCII or Unicode value, right? So this basically is also an integer and it is working fine. But once we start using long or long integer, we see that there is some issue. So it will say that incompatible types. Even if we do a float and let's say I change this to 5.0, it will complain that switch value is incompatible. So we will revert back to int and I'll change this literal to int 5 and everything should be sweet. Now we will quickly see how to work with string. So I quickly define a string value. So let's say I define a string with switch value string as, let's say, Manali, a hill station. Okay. And I will write the switch statement with switch val str. And now I will put the case literals. So case I will put as, let's say, Ajmer. And then I will do a sysout and then print matched Ajmer. And then I'll put a optional break, move to the next case. Here I will put Manali. I again do a sysout and I print matched Manali. Put the optional break once again. And I'll put the optional default, though I know that this is going to match the Manali case block, but still just for the sake of using the default and still go ahead and put it. I'll put like start touring India, our country. So now once we execute it, ideally we should be seeing this matched Manali string being outputted. So Shift F10, run the code, we see matched Manali is getting printed. Now we will actually check a quick use case where we will use enumeration. So first of all, what is this enumeration, right? So enumeration is basically like a class only. We don't need to instantiate enumerations using the new keyword. It has exactly same functionality as other classes. Like it can have constructors, variables, methods, and implement interfaces. When we will see the Java inheritance lesson, right, it will make more sense that an enumeration cannot inherit other classes, or we cannot extend the same. Also, one thing is that since we are in the main method, we cannot go ahead and declare an enumeration within the main method. So we have to move out of the method and declare it. So we can declare enumeration within a class, but not within a method. So I'll quickly create a small enumeration as follows. So I'll move out of the main method. I'll create a private enumeration. I'll be explaining what these access specifiers such as private, public, protected does in a future lesson, but for now just bear with me. So private enum is the keyword which declares this particular type as a enumeration type. So I'll, let's say, use traffic light as an example, and I'll go ahead and create the enumeration members. So I'll write red, yellow, and green. So these are basically constants which are part of this enumeration, right? And now we will use these constants in our switch statement. So again, going back to our main method, within the main method, what we can do is we can write one more enumeration such as this. First, I'll just type here checking with enumerations. Then I'll define traffic light. Traffic light, let's say it's a green, right? Then we will write the switch. So within the switch, actually, you need to use the enumeration reference that you have used. So we have just declared traffic light as a enumeration reference. So I'll use that value in the switch statement. Then I'll open the switch block and then I'll start defining the cases. So case is like it can be a red. So if it is a red, it will print out light is red. Then I'll put the optional break again. Case if it is yellow, I will print out light is yellow. Put optional break again. Then case, let's say, is green. And then put a block here, light is green. I'll put one more optional break and put a default statement saying that you should not jump the signal. Should not jump the signal. Okay. So with that, we'll try to execute it. Since we have defined the traffic light value as green, I am expecting this line to be executed. Let's see what happens. So I'll run the code with Shift F10. And there you go. The light is green is getting executed. One thing to note here is that when we are using the enumeration constants such as red, yellow, and green, we should not be putting the fully qualified name for this particular enumeration constant. Like if we try to do traffic light dot red, then this will actually result in an error. If you highlight the error, it will say that the enumeration switch case label must be unqualified name of the enumeration constant. So you should not fully qualify the name of the constant. Just keep that in mind. Now moving on, we can use this switch case structure along with our if-else statement. So we have already previously seen one example in the nested if structure where we have used a student class and a student grade. What we will do is we will rewrite that example using nested switch and see how that works. So going back to our main method, we will declare two variables, int student class, that says 5, and char student grade equals to, let's say, a. And now we will start coding the logic. We'll start with the if statement. If student class equals, let's say, a, we are going to check three things. So if student grade equals sorry, there is a typo. This should be 5 and this should be a. If that is the case, we are going to output the message grade 5, very good result. Else if student grade equals to b, then we are going to print grade 5, good result. And finally we are going to print grade 5 needs improvement. So that is one if-else structure. Now we will combine the switch structure with the same if-else. So we'll do that for the student of class 6. So we'll write else if student class equals to, let's say, class 6. Here we are going to put the switch case. So we'll write the switch statement, switch keyword, then put student class, student grade, and then we will write, let's say, case is a. It should print out grade 6, very good result, and put optional break here. We'll do the same with grade B. Here we put grade 6, good result, put optional break once again, and we will put the condition which student grade does not match either A or B in the default class. So we write the default keyword as well, and in that we output in grade 6 needs improve. And we also had a else block which is covering students not belonging to class 5 and 6. That let's write now. Student doesn't belong to class 5 or 6. Now we will quickly execute and see the output. So currently it's student of class 5 with A. It should print grade 5, very good result. So we are getting grade 5, very good result. I'll change that to, let's say, B, and run the code. Grade 5, good result. We'll change this to C. Grade 5 needs improvement. Now we are going to the switch block, which is covered for students belonging to class 6. So in class 6, the student grade is A. Let's see what it prints. So grade 6, very good result. If it is B, it prints grade 6 good result. If we go with C, that will execute the default clause of the switch block, and we should get grade 6 needs improvement. And finally, if we put student class as 7, it should execute the final else block. So if we run this now, we should see student doesn't belong to class 5 or 6. So that pretty much covers the switch case use cases. We covered a lot of aspects of one of the most core and crucial constructs in Java. Let's keep the energy flowing while we dive deeper into control flow statements in our upcoming sessions. See you there. Bye.